Welcome to the next session, and here we are going to be doing an introduction to Lakehouse, a buzzword that I'm sure you've heard a lot about, but maybe you don't know a ton about, and so hopefully we can get that done here and now. Now, if you didn't just come from Rich Rogers' presentation on Encorda, allow me to introduce myself. My name is Chris Loeschel. I'm one of the partners here at PM Square, and what I'm going to talk about before we get into this is something that is very important, and that is giveaways. As we give people a few minutes to transition in and out of sessions, I wanted to remind you about these giveaways. We've got 17 different prizes in total, 17 ways to win. Let's talk about a couple of those. We've got our grand prize, which is this indoor-outdoor theater kit, and there's a number of different ways to increase your chances of winning. You get 1 entry for filling out post-event surveys. You get 5 entries for being, or 5x for being the #1 on the leaderboard, 4x for being the top 6 on the leaderboard, 3x for being top 10. I know I was in a high position this morning, not eligible to win, of course, but you need to get active on the app so that you can bump me off the top spot on the leaderboard and move yourself up and give yourself a better chance to win here today. Go to the app homepage for details on all giveaways, and then go to the scoreboard section to see where you are lining up. Also, we've got a Bose soundbar, and the way that you enter this giveaway is by attending this session, the Introduction to the Lakehouse. The winner for this Bose soundbar, valued at $250, will be announced tomorrow at the beginning of day 2. So with that housekeeping out of the way, I want to introduce Greg Khairallah. And so I'm pleased to welcome Greg. He's the director of AWS's worldwide go-to-market for analytics, and he's been with AWS for nearly 8 years. Prior to that, he spent time with Intel, Oracle, and what is now known as SAP. And Greg's focus is helping customers drive innovation by adopting cloud-native solutions that turn data into insights. Now, Greg served as an officer in the U.S. Army and currently resides and hails from Scottsdale, Arizona. As the title states, Greg will be giving us an introduction to the data lakehouse, and specifically how you could easily build a well-governed lakehouse to harness the power of your data and your analytics from many different purpose-built data sources. With that being said, Greg, come on in and tell us about the Lakehouse.
All right. Hello, everyone. Good afternoon. Good morning. As I mentioned, I'm Greg Khairallah from AWS, so I'll be going through Lakehouse. But more importantly, I think the idea of reinventing your business with data and how the Lakehouse concept can be core to that. And we'll go through some slides, then we'll have some time for Q&A. So hope this is a great session for everyone that was able to join today. So I think, to put the Lakehouse and just reinventing your business with data in context is really a couple of macro trends that we've seen and heard from customers over the past few years. And it's really just the central role that data plays, not just in decision-making, but really in being innovative and being able to deliver better services to our customers. And you think about, what's really the business value of a modern data strategy centered on the Lakehouse. And AWS worked with IDC on some statistics around, being able to generate more revenue, right? So it's not just about, getting more insights. Of course, that's still super important, but really, how do we take and monetize our data, right? What's the return on investment on making a change? And so particularly if I have on-premise systems, how do I think about breaking down data silos and moving to a modern data strategy with the Lakehouse at the center? And there's some interesting statistics around 415% ROI and 48% reduction in cost of operations by leveraging managed databases. And so lots of information that's available on the business value of moving to a Lakehouse. But also, like, what does it mean to be a data-driven organization? And besides the Lakehouse term, which I'll spend some time defining, I think this is really where I spend a lot of time talking with customers about is how do we make data an organizational asset? How do we make it accessible? And in today's modern requirements is, yes, there's a core set of internal analysts that need to get access to the data. But importantly, we want to think about providing data to third parties, to partners, to suppliers, How do we think about not just internally generated data, but also third-party data, and thinking about ways that this can, change the way our data architecture is actually designed. But then more importantly, how do you put the data to work, right? And there certainly is a lot of value in reporting and analytics, but really moving to more predictive and leveraging machine learning automation to help us make better decisions are all the core of what becoming a data-driven organization really means. Now, there's challenges, of course, right? I think all of us are aware of some or a few of these items. And so one is just the volume of data that's being generated from IoT devices, mobile devices, thinking about, particularly if I have the on-premise system, I might have a data warehouse and a data lake that are separate. How do I think about, these different silos of data that make decision-making difficult? And then, most customers I talk to have some kind of a strategy around machine learning, but really they don't necessarily have the deep mathematical skills or the resources or being able to pay for third parties consulting to help with that. And so, more we think about this democratization of machine learning and how do I make it more prevalent? And of course, depending upon the region, the industry, but really, security is job one, for everyone, right? Including privacy and complying with different state and federal and international regulations around data privacy are all, challenges that we hear along this journey to becoming a data-driven organization. Now, oops, sorry, I went the wrong way. Now, one thing that's actually accelerated this journey to the cloud and accelerated the Lakehouse architecture, including modern data strategies, has really been, the reality of the last 18 months that we all have lived through. And we've seen, decisions being accelerated, and just the importance of data and migrations to the cloud have become accelerated because customers needed to make better decisions faster, like unprecedented market changes. How can we think about using data to make decisions with uncertainty, right? But beyond just surviving, what are the unique characteristics of companies that have really thrived, right? Putting their data infrastructure to work, right? Think about some examples I'm sure we use probably in our day-to-day lives around Netflix or, gaming customers that are able to deliver massive online gaming and just this whole way that information and delivery and really that customer experience has changed, whether it's through online pickup or remote work, and really putting data at the center to help not just survive but also thrive in the current environment. And to do that, and really the heart of a Lakehouse strategy is centered around thinking about this concept of modern data strategy, where I'm able to leverage and think about the application first, and then leveraging a flexible set of purpose-built databases that are fully managed. And so moving to more database as a service, right? And not just having to make compromises on one database, but letting the application requirements actually drive the database technology that's used, whether it's relational, non-relational, log analytics, data warehousing, and really having this full spectrum that I can very quickly and easily adapt to be able to meet the needs of my business. And then also, mapping that back, to AWS services, across Amazon Aurora or DynamoDB and SageMaker and EMR and Redshift. And we'll go through a little bit of those details, how it relates back to the Lakehouse architecture. But knowing you have this full flexibility by looking at AWS and AWS native services to help drive your modern data strategy can really accelerate not just cost savings, flexibility, but really think about this idea of monetizing my data and being able to react faster to market conditions. For those of you who are fans of YouTube videos, there's a lot of great information from previous AWS reInvent, which is our annual customer conference, that are up on YouTube on sessions of not just how customers have leveraged, AWS customers have leveraged the modern data strategy, but as well as Amazon retail business and its transformation from a monolithic database architecture to a modern data strategy. And if you're curious about the bigger picture here, I'd encourage just looking up some of those sessions from previous reInvent talks on how companies including Amazon.com, have leveraged a modern data strategy to survive and to thrive. But when it kind of breaks down, I think kind of like going maybe a little one step deeper, we think about this road to the modern data strategy as really having three different pillars. And they're not sequential in terms of you have to start with one and then progress through the others. Depending upon the application and the needs of the business, you can actually start at any place. But really, I think when we kind of work with customers to think, what's my data strategy? We need to modernize, to unify, and then to innovate. And I'll tie back how that is to the Lakehouse in subsequent slides. But first, I want to think about, again, this isn't necessarily a linear progression, but oftentimes modernization as the journey to a modern data strategy. And to modernize, you want to be able to leverage, the best of a scalable infrastructure, security, of course, being job one, but really moving from, commercial perpetual license type deals and really the old guard database infrastructure to a modern infrastructure. And I'll just give one quick example and we'll get into some details, but I think a great, short case study is around Samsung and how they moved from old guard database on-premise to Amazon Aurora, right? And so some of the statistics here, being able to migrate 1.1 billion Samsung accounts to Aurora with really minimal to no service disruption, right? But then also, thinking about this critical workload that is at the heart of Samsung's business in terms of delivering features to their customers, but being able to do this migration of these complex workload in about 18 months, right? But being able to look at not compromising on performance and being able to reduce costs are really at the core of the Samsung case study. And there's more details available on AWS's website if you're curious, but just kind of give you a sense of this modernization and moving from, monolithic legacy, systems into a modern data architecture with Amazon Aurora at the core. But moving this legacy infrastructure requires a lot of and why do customers actually invest in this movement is because these on-premise database systems oftentimes come with a lot of heavy lifting, right? Now, my personal history, I spent a number of years across on different providers like Oracle, and look, in the 1990s, 2000s, this was standard practice. Hardware had to be delivered. We had to do performance, scaling, capacity planning. You had to purchase, servers and racks, and then compliance, and then perpetual license deals and audit licenses. And I mean, this was just pretty much the standard, right? And today, there's a different world, right, where I can just pay as you go. I can remove some of that undifferentiated lifting and think about this world of managed or database as a service, right? And when we think about database as a service, one of the important lessons we've learned is that there's rarely one database that can meet the needs of every application across the enterprise. Now, certainly, not to say you have to use every database in every application. We're working with our customers and partners and AWS solution architects to really come back with a recommendation, but knowing you have this flexibility, right, across relational, key value, document, in-memory, right, ledger and time series databases, where instead of saying, okay, we've invested this hardware on premise, therefore, how does the application leverage what we have? Turning that around to say, what does the application needs? And of course, understanding how AWS is managing backups and patching are super critical, but those become more like plugging in an outlet, right? So the electricity is there. How is ability, right? And so thinking about, not to push that analogy too much, but AWS provides the electricity. In this case, it's the database, and not just a single database. And I referred back to the story of Amazon retail that was core to this, where today, whether it's moving from Prime Day to holiday season to shipping, logistics, the core to this strategy is really built around purpose-built databases. In the previous slide, calling out Samsung is really being able to leverage the right database for the right application, and really thinking about this application developers and choosing the right data store becomes core to this idea of innovation. Now, that kind of just set the stage as we kind of jump into more conversation around Lakehouse, but I think this modernization often becomes an important topic because we need the source systems that generate data, and oftentimes that's really where the application, and an application I mean it could be my mobile app, it could be my ledger, it could be the core, the heart of my organization oftentimes comes down to the database, and thinking about what that modern data strategy and that modernization piece becomes a critical piece. But then also we think about, okay, how do we get value from that data, right? What really breaks down that data silo? And the session is primarily focused around this concept we call Lakehouse. And by Lakehouse, we just really mean is this breaking down of data silos, where perhaps previously I would have a data warehouse and then separately a data lake. And at its core, Lakehouse says is that I have a unified set of data that, depending upon the workload of the analyst, whether it's a data warehouse, a data scientist, a program like Spark or Scala, or Python using Spark, should all be able to access that single data store. And that's really at the heart of unification of data. And so just a quick customer example from Equinox Fitness, right? They moved from an on-premise a data warehouse to this Lakehouse architecture that combined Amazon Redshift and Amazon EMR. And you can see here, there's some things around cost savings, right? But particularly if you're moving from perpetual license or on-premise licensing deals, in many cases, what you pay annually to AWS is a small fraction of what your annual maintenance was, let alone the initial license procurement up front or the hardware costs. But then more importantly, being able to rapidly adjust to changing market conditions where, you can move or daily, you can within the minutes or within the seconds, or real time from mobile devices, right? And one quick example, again, more details on AWS's webpage if you're curious about Equinox and some of the cost savings and benefits they saw, and examples across other organizations as well. But really, I think at the core of this, and coming back to our topic around Lakehouse, comes, and really this center place that the data warehouse plays in the Lakehouse. And there's lots of ways to deploy modern data strategy. This isn't the one one answer from AWS. We'd love to work with each of our customers and partners on really designing the right architecture for your specific needs. But some pattern along this becomes where most customers start. And so again, just to kind of define Lakehouse clearly, the premise of it is that most analysts in the organization probably speak the SQL language. And so we talk about and Scala, and all of that can be accomplished. Tools like visualization from Amazon QuickSight or Tableau or MicroStrategy, applications that know the SQL, and just this whole developer community really comes back this idea of a highly performant, highly available data warehouse at the core, but also knowing that what we said earlier around new data sources from IoT devices, streaming sources that are coming in from Kafka or Kinesis, log data, application data, but also this idea of third-party data and how I can monetize and leverage third-party data. So from AWS as one of our data sources, we have a service called AWS Data Exchange that has a large number of third-party data sources that you can leverage. And so moving beyond just internally generated data to third-party and market data, or even monetizing your data sets and providing that to your partners, excuse me, can become an important concept as well. But besides that, kind of idea of different data sources, another core piece of the Lakehouse then becomes, and not forcing loading all of your data into the data warehouse, whether it's Redshift or a different cloud data warehouse, but there's an important feature of Amazon Redshift called Spectrum that allows you to really combine the best of a data lake with the best of a data warehouse. And so you don't have to import the data into Redshift to get value from it. particularly for patterns that have data coming in as a stream, or leveraging if I have a machine learning team that is using data that is in the data lake. And so Redshift has a construct called external table that you can point directly to data on S3 without having to load the data. And as data changes, as it gets updated into S3, you can immediately query it. And this kind of comes back to this Lakehouse architecture. So I mentioned this merging of the data warehouse and data lake at its core, and features like Spectrum and like federated query really allow that to be a simple from the end user. So if you're a business intelligence user, data analyst, you simply see a collection of schemas and tables and typical database objects, right? That are all secured through access control. You can limit to third parties or to internal resources, but whether the data is local to Redshift, whether it's files on S3, whether the data resides in a completely separate database like Amazon Aurora, giving this simplicity to the data analyst to just seeing the common database constructs, but then not having to compromise on performance, I think are the core to the Lakehouse, and really Amazon Redshift being at the center of that Lakehouse architecture. Now, Amazon has been investing significantly in Amazon Redshift and certain features that really help enable this Lakehouse architecture. I'm not going to go through each one line by line, but just knowing that the pace of innovation continues, and we're excited, in the coming months to share even more how we've evolved Amazon Redshift, just given how the criticality of the data warehouse workloads to Lakehouse approach, and knowing that the full investment of AWS behind Redshift as the core cloud data warehouse to help our customers. But a couple of things I did mention to Lakehouse I wanted to call out that really help rethink the way the data warehouse is deployed, and really helps accentuate this concept of breaking down data silos with Lakehouse. And the first is a feature of Redshift that we launched called data sharing. And so, just kind of going back to my analogy from my previous employer, Oracle, it was great, great database, one of the best databases in the world. I loved my time at Oracle personally, but there was a different perspective, right? Where you had these monolithic systems like Oracle Exadata, and it was about managing and managing resources on that single cluster, and workload management, performance tuning, which were all super critical to deliver. But today, thinking about like a layer in Redshift that we call Redshift Managed Storage. And so this is really the persistent state of the database, right? But now instead of having a single Redshift database or cluster connecting to that Redshift Managed Storage, you can have multiple independently sized data shares that are compute resources that connect to that storage. And so with Redshift, you have the separation of compute and storage, but then the flexibility to say, well, the pattern at the left says I might have a batch process that runs 24/7, and so I'm going to have a certain sized, quote unquote, data warehouse to just do that ingestion of the data. But then I have different business groups that need a consistent view of that data, right? But they need to have that segregated out into their own compute pool for SLAs, right? And so you could have, here we have 3 examples called a data science cluster, dashboarding cluster, ad hoc query cluster. And this idea of separating out into their own compute pools, but not saying it's any sort of like eventual consistency here. This is a fully consistent data model that's at the heart of Redshift being an database, right? The table is updated immediately. Any of the compute pools that are accessing that will see that same view in a completely read consistent manner. And so this first pattern at the left, where I have different consumers of that data, they can be in the same AWS account, different accounts, eventually even across spanning different AWS regions, whether it's internal, third parties. If I need to share data, I can simply share an endpoint and have external parties securely start sharing that data. But the other piece of data sharing we see a lot is kind of the second idea on the left, on the right, where there's no central sort of ingestion piece, right? It's really about each of the different business units or partners, whether it's finance, research and development, marketing, just a few examples, right? They all have and subscribe to a common set of tables, that are fully consistent, but they might have their own data they need to ingest in there as well, where there really is no central place to singularly do updates. And so this idea of data sharing, really kind of helps accentuate this concept of Lakehouse, because now I can deconstruct what otherwise would have been a monolithic deployment from a data warehouse perspective into the individual business units and think about what their SLA and what their compute resources are without having to do performance tuning or resource sharing, because they each have their own share that they can then operate on. Also behind that, and I think core to this idea of Lakehouse, is really this democratization of machine learning, right? So I talked earlier why we put Amazon Redshift at the core of the Lakehouse architecture. It's because it's ubiquity of SQL language, right? And certainly there are lots of tools to be able to build, test, deploy ML models in a wide variety of programming languages. But for the Lakehouse user, for the data warehouse user, just being able to simply select a data set in Redshift, provide that as the training set, right? And then automatically behind the scenes have a function called SageMaker Autopilot, determine the right ML model, and then deploy that model back into Redshift, leverage it through a SQL statement. And means, we provide that insight into SageMaker Autopilot, but that's really transparent to the user of the database, right? They simply are using SQL to issue commands like create model, and then once that model is created, being able to select it. And whether you have SageMaker Autopilot select the model for you, or whether for more advanced users you want to specify the exact ML model, the process works the same. And so data stays within Amazon Redshift. You get to be able to leverage the full capability of the Lakehouse architecture, but really the simplicity of just the SQL language to be able to leverage machine learning, where you don't have to be the PhD in math to get the value from this data. And the other area that comes back that we've invested from a Redshift perspective as it relates to Lakehouse is native support for semi-structured data. So there's lots of different approaches to be able to solve this problem, to be able to think about a JSON file, right, that is nested. And what's unique here is that the file itself defines the schema. So in previous versions of Redshift and other databases, if I had a JSON file, I would have to specifically map each attribute to a table in Redshift, right? Whereas today, like with our super data type, you simply have, in this example, you load it into Redshift, copy command or ETL processing tool, and the file itself defines the schema, right? So I'm not predefining the schema. And if I need to query it, using the dot notation of SQL, so not just querying the document itself, but querying the individual nodes in that document. And so this can greatly simplify the end user experience, because they simply have a JSON file. It's loaded into Redshift in a single command. The document itself defines the schema, and now you can start doing standard SQL operations against that to really simplify the data pipeline, but more importantly, unlock this value of what otherwise was non-traditional data source from a data warehouse perspective. That is really this idea of breaking down data silos as the heart of Lakehouse is a great feature that customers have been excited about to leverage within Redshift. But there's also kind of a different way that Lakehouse plays in terms of unification of data. And I talked a lot about the BI users, the data analysts, to be able to leverage this power and not having to make trade-offs between data that's local to the database or data that's external that features like Spectrum and Redshift can deliver. But there's also a large set of applications that need to be written that actually leverage, where the end user of data from the Lakehouse is not a Tableau report or QuickSight report, although that is obviously still a large use case, but really leveraging data within the Lakehouse or the core data. And the application itself needs to be written in languages like Java and Python or C, and this full spectrum of different programmatic ways. And so Redshift has a full data API where the connection does not happen through ODBC or JDBC, but it's through the API itself. And so, we've actually seen, thousands of customers leverage the API that are making, tens and hundreds of thousands of API calls to be able to really, think about these data-driven applications and not just the data-driven reports. And the full functionality of Redshift, from machine learning and data sharing applied to the API, whether I'm a data scientist using a notebook or a SQL command prompt, or that application that's serving up data, can become really powerful in terms of breaking down the data silos that is at the core of the Lakehouse value proposition. But knowing that, I mentioned a little bit about, and probably a few slides on the house part of Lakehouse, right? But there's still that data lake piece, right? And so at the core of the data lake becomes, the value of Amazon S3, right? And thinking about data frameworks outside of just SQL to be able to access that data. And so if I have, these big data formats like Apache Parquet, if I have data engineering processes where I have data pipelines that I'm building, of which some of that data might get loaded into the data warehouse, some of it might remain separate. And really thinking about the power of Amazon EMR and being able to have flexible deployment mechanisms to be able to think about how this data is used. And so within Amazon EMR, we have invested a lot in the most performant and cost-effective execution engines for Apache Spark. You can deploy it on EC2 instances within Kubernetes, right? Containers as part of Amazon EKS. And really leveraging some of the foundational elements of the spot market on AWS to really drive cost savings, and really thinking about this data engineering pipeline side of the Lakehouse, and putting Amazon EMR at the center of that becomes an important way to think about driving efficiency and really breaking down those silos as well. So I talked a little bit about, the modernization, the unification, and now just the last couple of slides to think about innovation, right? And more innovation is driven by machine learning. And it's been a core investment of AWS to really make machine learning available to a larger set of users to really see the value and power of ML. So here's a great example. I'm a big pizza fan myself. Love Domino's. And they started off with this challenge of reducing their pickup and delivery times for online orders, right? And so remember earlier in the talk, I mentioned how the current pandemic has changed the way business operates. And a great example of being able to quickly adapt is Domino's to this new environment, right? So as online ordering increased, they wanted to reduce pickup and delivery times. And they really looked at Amazon SageMaker as really the core enabler to develop these forecasting models, and able to then, their stores to be able to, meet their business goal of delivery time in 10 minutes or less by really thinking about, and quickly being able to assemble data as part of the Lakehouse, and leveraging SageMaker to be able to build, test, and maintain those models. And more details on customers that have leveraged machine learning that we can share. But at the core of machine learning and really this innovation is really the flexibility that AWS can provide, wherever part of the spectrum of ML you come in. And so at its core, for builders, for developers, we have the machine learning frameworks and infrastructure, the ability to run MXNet, TensorFlow with the latest GPU processing units, right? With purpose-built hardware that can really accelerate for the builder, for the developer, for the data scientist to be able to leverage the power of machine learning. But more and more we see customers such as Domino's earlier that are leveraging an integrated development environment known as SageMaker and SageMaker Studio. And it really can leverage the full spectrum of machine learning, from data preparation, a feature store, a visualization in notebooks, picking algorithms, training and deploying and monitoring those. And so the power of SageMaker at its core to leverage data within the Lakehouse, it really helps drive the innovation for many customers. But then thinking about beyond just that component in the AI services. And so if we kind of thinking about, I just have an application, I want to be able to leverage a chatbot, right? And so being able to use things like Lex and Poly to be able to do text to speech or speech to text to comprehend and translate and text track. and really just thinking about the application that's needed to then empowered by the AI services that really helps and democratizes this access to ML across a full spectrum of data. So that's kind of the end of I know we still have a few minutes left. I'm happy to take some questions, but really, at the heart of the Lakehouse is breaking down data silos. At the heart of breaking down data silos is this concept of a modern data strategy. And depending upon where you are on the journey to the cloud, thinking about modernization, unification, or innovation become core pillars to really getting more value from your data and being able to rapidly adapt to modern data needs, but also make innovation the core of how we deliver that. So that's the end of my talk, and happy to take some questions from here.
Excellent. Thanks so much, Greg. And we do have a number of questions for you here. We'll jump right in, get to as many as we can in the time we have allotted. And then for any questions that don't get answered, we will send them out after the event in some sort of communication. So let's start right here. So this is very interesting. Where do you start? There's a ton of great capabilities and technology, but if I'm currently on-prem for my data warehouse and analytics, how do I even start to move to this world?
Yep, that's a great question. And I guess I was deficient in adding this slide at the end, but AWS has a number of programs and partners that specifically, help customers along this journey from where you are today to kind of the concept I outlined here. And it really starts with this assessment piece, right? And so this pillar in the middle, a modern data strategy, like what does that mean? There is a set of talented individuals at AWS who came from industry, came from business that have helped solve this problem and now really become evangelists in helping customers define that data strategy. And so internally, we call that program data-driven everything. And it's not a consulting or professional services or paid engagement. It's simply a way, to help strategize with the output, after a week or two of the outline of what that data strategy should look like, right? And oftentimes in that, we identify what's the first use case or the first test case that we can then move into some kind of prototype or pilot. And to help with that prototype or pilot, AWS has a program called Data Labs that is it's not meant necessarily to be AWS training, but it's really this rapid prototyping environment where, we can, within a week or two, take some of the outputs from the strategy and test them out and see if they have the value, right? And then from there, AWS has professional services as well as a large network of system integrator partners, global system integrators as well, that can really help implement that strategy. And so, when we think about moving from on-premise, particularly for larger enterprises, but really maybe size doesn't matter, I think prioritization and focusing on innovation. We do see cases, or I have seen cases where it's like, okay, I have a date. It's a year from now. We have to be out of our data center for whatever reason, right? And then it becomes a bit of, hey, we just have to move, right? Or if I just say, hey, I know there's this concept of moving to the cloud, so let's just start doing it. And okay, there could be some success there, but really thinking about working backwards from like, what's that end state that we want to have? And at Amazon AWS, we use a process called the press release and frequently asked questions. And one of the outcomes of these workshops we work with customers is like, think 2 years from now, like it could be a press release to your customers, it could be an internal press release to stakeholders, but like, what is it that you want your data infrastructure to deliver and innovate on? And then think backwards from that in terms of what is the data architecture that supports that is really the core of that. And AWS would love to partner with our customers to help define that strategy and that prioritization, and then give you the resources to help scale through partner system integrators or AWS professional services along that journey.
Excellent. So this next one is kind of a high-level question, and I wonder if you have a good way to give someone who's just learning about this space an understanding. What are the similarities and differences between data warehouses, data lakes, and data lakehouses? I know you waxed pretty poetic about it during the course of the presentation, but for someone who's just looking to mentally be able to draw the lines and conceptually understand really the differences between the three approaches, what would you tell them?
Yeah. Well, one, I think starting, I think, small and growing. So, there is an example, it's a public case study in AWS I use sometimes, but the NASDAQ marketplace, right? I'm sure we're all familiar with NASDAQ. They approached AWS and said, hey, I have this legacy on-prem data warehouse that we need to get off, right? And they looked at different cloud data warehouses, did their evaluation, decided on Amazon Redshift, and effectively they moved, what they were doing on premise in their data warehouse to doing what they did in their data warehouse on Redshift. And they got cost savings, flexibility savings, all that great stuff. But fundamentally, they moved a data warehouse from A to B, right? But then they found, hey, like the size of the data warehouse, there was new data sources, there were, compliance reasons. And so they started, accumulating data on Amazon S3 in a variety of different formats. Not all of that data necessarily required instant analysis through the data warehouse, but they needed access to it, right? And so they started developing, schemas and tables and concepts around what we now call the Lakehouse, which really just means that, combining the structured and unstructured data to some level, but also, thinking about the full breadth of analytics, whether it's, 99% of my analytics might be derived from the SQL language, but for that 1% or 5% or 10% that needs, the data science workloads that needs a Python and a Jupyter notebook, like how do we provide the same security, the same infrastructure, the same data? And I think that's kind of the core of how this Lakehouse architecture started to evolve. But the first thing I would say is that, you don't have to move immediately to a Lakehouse. It's really the needs of the application and business that will drive that, and really this concept of working backwards. And so if you're more familiar with database constructs, thinking about features in Redshift specifically, I mentioned like data sharing and support for unstructured or JSON data types as a database object, really helps provide that first step, right? And then you can then think about what additional needs that are required, that where the data warehouse doesn't always provide the answer, right? And it's that flexibility that I think is at the core of Lakehouse or data lake and data warehouse and these terms. I mean, they're all, to some extent, they're all kind of marketing terms, right? But like at its core, I think is how do you get value from the data? And if you think about just putting data in one place, there's a simplicity argument, and Redshift can do that. I mean, talk about some of the features that can provide that flexibility, but at the core of the Lakehouse is this combination of not just data formats, but actually use cases, right? And not having to duplicate data that then think about, the data scientist, the data analyst, the data engineer, and what are their needs? And what's this unified architecture that can solve all of that? So hopefully that was clear, but I think, yeah, I'm happy to.
No, that was excellent. Thank you. So next we have a question. Does data ownership necessarily have to change when shifting from a traditional data warehouse mold to more of that of a modern data lakehouse?
I mean, I guess my initial answer to that would be no. No, but right. So there still is someone who owns the data, who owns the schema, right? And it can be a distributed model, doesn't have to be one person, but at the end of the day, a person or a group of people or different groups of people are saying, okay, I've got schemas. These are the groups that get access to those schemas. Then within those schemas, there can be, tables, columns, rows, cells that I need to then, authorize, right? So in that sense, I think it's very similar. I think where it becomes different is, I touched this earlier, might have spent too little time on this, but this new concept of a data marketplace, right? And on the AWS side, it's things like AWS Data Exchange and how customers want to leverage third-party data, monetize that data, or collaborate and share on that data, right? So the biggest gap, I think, or the change, I think, is where we kind of take that basic authorization construct, but now say I don't just have internal users that are part of my Active Directory or LDAP domain, but I have third parties, I have partners, I have customers, right? And what's the right, authorization model for a third party to be able to get access to that data, right? Without having to duplicate the data, for instance, right? And so I think that's really where the change comes in, which isn't, it's not a change in terms of what that person who owns the data does. You're still granting access to data, but thinking about that third-party piece, I think, becomes important as part of that data marketplace conversation.
Excellent. Next, we have someone asking if you can expand a bit on federated queries.
Yep. Thanks. Yeah. So there was two at the Lakehouse construct I talked about. There were two features in Redshift that help build this Lakehouse. The first is a feature we call Spectrum, right? Where the data is not local to Redshift. It's a CSV file, it's a Parquet file, whatever file format it is, that we just simply have an external table in Redshift that points the data on S3. And then Spectrum has a fleet of compute resources that are leveraged when you want to query the data. So fundamentally, to the data analyst, it looks as if the data is local, but actually from an infrastructure perspective, it's not in the Redshift format effectively, right? The query federation comes in and builds upon that. So I still have this external table construct, but now the data is in a Postgres database or MySQL database today, right? Those are the two primary databases. And so this idea of combining the transactional data with historical data, right? There's lots of theories of best ways to do that we can go on for, but at its core, a federated query says, okay, I've got data in MySQL or Postgres today, and I want to query that and combine this quote unquote real-time data with historical data that might be traditionally in the data warehouse. And so a federated query pushes the SQL query directly down to the Postgres or MySQL database, and then returns the results set back that then can be combined with historical data. And so this kind of Lakehouse piece of data on S3, data in other databases, but a single schema that maps across all of those, and then federated query can then push the queries down to those external data stores without having to move the data necessarily wholesale into Redshift through data engineering or ETL pipelines.
We've got time for one more final question here, so we'll ask it and then get you out of here, Greg. And again, thanks so much for the presentation. Definitely some very valuable insight for our clients and prospects on the line here today. A final question for you is, will AWS Glue support the new super data type?
Yes. That wasn't easy. So it will. And so the longer answer is, I'm sure if you've read about, Amazon or AWS, you might be familiar with this term two-pizza team, right? So it's just how we develop our teams to be able to move quickly, right? So, we didn't wait to release the super data type in Redshift for the Glue team to be able to fully support it. I mean, of course, we'd like to have that different priorities, but so they might not necessarily be, super data type was released about 4 months or so. And so the Glue team, as well as, other, ETL or ELT tool providers are, working with the Redshift team to support super data type. So today, the most common way to use is simply through the Redshift copy command, and the copy command does support a super data type today, and tools like Glue and other third-party ETL tools will be supporting that in the coming months.
Excellent. Well, thanks so much, Greg. Excellent presentation. Thanks for entertaining the questions that we have. If anyone had any questions that didn't get answered, you will definitely have a follow-up communication. And if you have questions you didn't get a chance to answer and you want to, definitely seek other areas to engage, whether in some of our networking sessions later today or early tomorrow morning. So as far as where we go from here, so I'll go ahead and pop open my screen. Coming up next, we have got in 15 short minutes a strategy session called Can Data Mesh Fix Your Data Mess? Going to be presented by PM Square. And there are all still appointments available for our Genius Bar, such as our Cloud ETL Genius Bar tomorrow at 3 Eastern Time. And that's going to be following our Lunch and Learn on the Amazon Glue to build on some of the concepts that we talked about today. Now, we also have upcoming AWS workshops. On Thursday at 11 a.m., we have a hands-on with Amazon Redshift workshop presented by AWS. And then at 3:30 Eastern, we have a hands-on workshop with Amazon QuickSight, also presented by AWS. Make sure you check out one or both of those. And then last but not least, let's make sure we don't forget about the Bacon Hangouts feature. That is going to be active at 3:30 Eastern today, so in just under an hour and a half. You'll have an opportunity to take part in group conversations. You can choose the topics that PM Square has hosted, or you can choose to jump into a topic that has been custom created by one of our attendees. Either way, should be a great chance to network, meet fellow birds of a feather in whatever your areas of interest are, and an excellent opportunity to deepen your engagement with the conference. So with that being said, we'll close up this stream and then see you on the next one.